Hey there, ever wondered what really happens when you type a prompt into GitHub Copilot and get a suggestion back? In this video, we'll break down how Copilot processes your prompt, gather context, and generate accurate, safe responses, and how you can make it smarter and safer for you, not just faster. It all begins with user prompting. Think of Copilot like teammate. The cleaner you are, the better the help you will get. If you want clear, faster and more accurate AI responses, remember the forest prompting: single, specific, short and surrounded. First, single. Focus on one request at a time. Multiple questions can confuse the model. Next, specific. Vague prompt make Copilot guess and often guess wrong, while specific prompt generate accurate, useful suggestions. Third, short. Keep prompt concise. Shorter prompts reduce noise and increase accuracy. Last, surrounded. Include relevant context like files, code, or comments to guide the model. Now let's walk through a few examples so you can apply this same principle in your own projects. If you are working with multiple programming language, include language-specific keyword and syntax in your prompt. This helps Copilot understand exactly what you need, such as converting a file code from Node.js to .NET. Copilot picks up both your intent and specific source and target language. Copilot remembers context, so follow-up built on prior prompts. Multi-turn conversations let you refine answers and get deeper, more detailed guidance. Zero-shot prompting means you give Copilot a task directly with no examples. It works well for common tasks that Copilot already understands. Sometimes, you might use few-shot prompting, giving Copilot a few examples before your actual prompt, so it understands the pattern. Once you type your prompt, GitHub Copilot doesn't treat it as just text. It gathers context from multiple sources like open file, surrounding code, file names, open tabs, and even your previous chat messages. The better the input, the better the output. One clever trick it uses is fill-in method, looking at what's above, below, and at your cursor to generate suggestions that fits naturally in your code. If you're using Copilot Enterprise, it can also draw from your organization private repos and knowledge base for even more tailored suggestions. You can guide its focus with variables like hash edit files to target specific file or section. And here is something equally important. Function naming matter. Avoid generic name like do this or temp function, which gives little insight. Instead, use clear descriptive name like get all products, which act as a mini prompt for Copilot. Before GitHub Copilot sends your prompt to AI model, it runs two important checks: preprocessing and content filtering. Preprocessing trims unnecessary details, restructure the prompt, and keeps only most relevant context, boosting both speed and accuracy. Content filtering screens for harmful or inappropriate languages using toxicity filter, blocking things like hate speech, vulgarity, and personal data from reaching the model or influence suggestion. Together, these steps make Copilot response safer, faster, and smarter. And if you have excluded certain files or data from being used, Copilot respects that. It won't use those files in its suggestion, keeping your boundary intact. Now an important point: bias. Like many AI systems, Copilot can reflect bias from its training data, and it's still evolving. That's why your judgment matters. Think of Copilot as a co-pilot, not autopilot. You are still the captain. Once your prompt is filtered, it sends it to large language model behind the scenes. It interprets your request, uses context, and generates smart, context-aware code suggestions that fit naturally in your actual code base, not just isolation. After generating the suggestion, Copilot deletes your prompt, It doesn't store or use it to train its model, keeping your data private. So, what makes this LLM so powerful? They are trained on massive amount of text and code across many languages and frameworks. By learning patterns and context through machine learning, they can generate code that's both accurate and relevant to your work, even without custom training. Unlike traditional static analysis tools that simply scan for bugs, GitHub Copilot understands your code and intent, providing broader, smarter suggestions to enhance your workflow. Once the model returns a suggestion, it's routed through a GitHub proxy server for final check before it reaches to your editor, ensuring it's safe and appropriate. Copilot speeds coding by cutting manual searches, trial and error, and rewrite. It collects usage patterns to improve accuracy and relevance based on real-world feedback. GitHub filters responses and uses feedback to make Copilot smarter and more reliable over time. Even after validation, Copilot applies a final safeguard, post-model filtering, to protect both users and the open source ecosystem. If Copilot suggests 150 plus characters matching public GitHub code, Copilot discards it. It removes white spaces and compares the text against a large public code index to avoid copyright or security issue. In settings, the suggestions matching public code option let you block exact matches, lowering potential risk. These filters often flagged in common code pattern like login form, sorting function, or API call. Flagged suggestions are replaced with new ones. With post-model filtering, GitHub Copilot ensures your suggestions remain safe, useful, and unique, aligning with your project's need and value. Once a suggestion clears all filter, from safety check to duplication detection, it delivers straight to your editor, ready to integrate in your code base. With multi-file and inline editing, you can work across multiple files with real-time preview, ideal for large or complex tasks. These suggestions appear instantly in your editor, so you can apply, test, and refine without breaking your flow. Copilot Chat predict and generate code that fits your current context, aligning with your existing style and structure. Use the editor for quick completion. Use Chat for deeper tasks like explanation, debugging, and improvement. And throughout the process, Copilot boosts code reliability by suggesting improvements such as error handling and input validation, helping reduce bugs. At the final stage, the most important part comes in you. After all the AI processing and filtering, it's your job to review, decide, and refine. This is where collaboration meets accountability. Even the best model make mistakes. Always check suggestions for accuracy, project fit, and coding standard. Be extra careful with sensitive or critical code. Apply the same scrutiny as human written code. If a suggestion isn't right, tweak your prompt and try again. That back and forth is what makes Copilot Chat so powerful. Your code is your call. Code may look fine but behave unexpectedly. Your judgment is key. Don't let Copilot do all thinking. Over-reliance can weaken your skill. You should understand code before you use it. Large code blocks generated from short-term prompt can hurt quality if you don't catch them. The better your prompt, the better the suggestion. Ensure to write clear problem statement, good variable name, and example to improve result. So that's how GitHub Copilot works behind the scene. From prompting and context gathering all the way to context filtering and suggestion generation. We have explored practical prompt strategy to make Copilot Chat a more reliable coding partner. In the next video, we'll break down advanced prompting technique used by experienced developer to handle more complex scenario. If you found this useful, please like the video, subscribe to stay updated, and let us know your thought or question in the comment.